Hello and welcome to another video. In this video we're going to be doing the next problem in the 2000 plus, and so we're going to be doing digit count and range. And this one you have an integer and two integers, low and high. Let's do a timer. Return the number of times that digit occurs. Okay, so from 1 to 13 it occurs 6 times, so 1, 10, 11, 12, 13. Okay, so 1, 2, 3, 4, 5, 6. Okay, twice in 11. Okay, 300 to 50 occurs 35 times. Interesting. Okay. Alright, so obviously, like, you can't just like go through every digit and count for the number of digits in it, or every number, because that would just be like an easy. So we need some better. So I think we need to do like digit DP in here. And the basic idea of digit DP is we're essentially doing a DP through a number, and we're just trying to see like what digit can we make this current thing. And there's some things here that are kind of difficult. So if digit DP, let's say our number happens to be this. Like, whenever we pick the first digit, we can pick anywhere from 0 to 4. And if we happen to pick a digit that is smaller, like let's say we pick a 2 here, then the next bound can be 0 to 9. But if we pick the exact same thing that we had, like we basically have to keep track of like, did we ever pick something smaller? And if we did, then our next digit can be 0 to 9. If not, our next digit can only be 0 to whatever this top thing is. So like here, we picked a 4, we can't pick a 9. So we need to keep track of that. So I guess in digit DP, you need to keep track of like index. Did we pick smaller? Our numbers, we can turn into a string. And then there's also like a leading zeros problem. So we need to keep track of like, do we actually have a number, or is it just leading zeros? Because imagine our range was like 1 to a million. Like, how do we count for like 20 or something? I mean, we could say we just put in a 0, but we don't want to count this as a 0. And we actually want to have a number at the end, so we can't return like 0, for example. So I think we can have a variable there as well, like number. Did we pick smaller? Is it a real number or something? Or is it just leading zeros? And I think we also need to keep track of like how many digits, like in this case, how many digits of the one we are looking for. Like normally you don't really need to pass that down recursively, but in this case I think we do, because like let's say here we pick a 1 in the beginning, we actually need to know like how many recursions did we make, and then for all those we need to know how many recursions did we make, and so on. Or actually we're only gonna make one recursion, right? So from like, let's say our number is like 13, if we put a 1 here, we're only gonna recurse once from this 1, but this 1 actually appears a bunch of times. So in every recursion we need to like keep track of like how many ones did we have so far, because each one of these needs to return a 1. So I think it's gonna be like how many digits we're looking for, and like digit count encountered or something like that. And then basically for digit DP, the way to do this like low to high thing is you usually just do like 0 to low minus 1. And then you do a 0 to high, and then the difference will give you that, right? So for example, if I want 10 to 25, I'll do like 0 to 10, how many times did I see it, or 0 to 9, and then 0 to 25, and then the difference will give me low to high. So that's typically how you do it. So we can just make a function call twice. Alright, so let's try to do this, and I haven't done this in a while. So we need like an index. We need the number we are like using, that's going to stay the same. And then let's see, what else do we need? Oh yeah, so those things that I said, right? So the index, the number, like that is number. Is it actual number, or is it just leading zeros? And then the other thing is like, can we use smaller now? So like maybe like a limit or something. True or false. Oh yeah, and digit count, right? Digit count. Yeah, so our base case will be if I equals length num. So if it's all leading zeros, then we're not good, but anything else is fine. So we can say return digit count if is num, else 0, I guess is fine. So basically if it's all leading zeros, like we actually have to have a number, right? So if our number is all leading zeros and we want to try another leading 0, then we can have that case. So we can set it equal to that. So we can say like result equals 0 if not is num, then we want to maybe try just another leading 0. So that's just going to be result equals dp I plus 1. Num will be the same. Is num will be false. Limit will be, yeah, so we could have picked the digit, but we picked the 0, so limit will be false. And digit count will be the same, because we don't want to count leading zeros. Right. Now we want to pick the left and the right boundaries. So left, like what are we allowed to pick? So left, I think, just depends on the limit. Yeah, left depends on the limit. We also can't pick a leading 0. Like in this part, we already handled, this is the leading 0 case. So now we can't pick a leading 0. So basically we can check. Yeah, we essentially can't pick a leading 0, so we'll just start at 1. Actually, if it's already a number, we can start at 0. But if it's not, we'll start at 1. Yeah, I think that'll be fine. Hopefully, we'll see. Okay, so left equals 1 if not is num, or I guess, yeah, else 0. Okay, and the right bound will be, so the right bound will be it can be 9 if we don't have a limit. So right equals 9 if not limit, else num I converted to an int. Okay. And that's basically like, if we already picked something smaller, now we can pick anything. All right. Now we just need to go through these. So we need to say for j, range left, right plus 1. Okay. So plus, so what's our recursive case? So it's always going to be I plus 1 here. Num stays the same. Is num. So if it's not is num, let's see. So is num will always be true because we will never pick a 0. So this is true. I believe. Yeah, that's true. Limit will be, if it was already not limit, then it'll stay not limit. So I guess we could start it off with false and then we can make it true, in fact. Yeah, we can do it kind of like the other way. Or maybe we can say like no limit. Okay, yeah, let's do it this way. So where did I say that? Okay, so right will be if no limit. Yeah, so we'll change it this way. Okay, and then let's also check. So this is also no limit now, so this is true. Okay. So num, it will be a number. The limit now will be either no limit, so no limit, or we pick something smaller than the number. Num I. All right. And the digit count will be, so it's the old one plus j equals the digit, I guess, or d. Okay. Let's see. So we can do this. Did I screw something up? I don't know what's there. Okay. Now we return the result. So now we want to call this function on, yeah, so we basically want to return the function call here on high and then low minus 1. Yeah, I don't know if we're going to get on 0, so let's just kind of void. Okay, so right will be dp of 0, high, or string high. It won't be a number yet. False and 0. And so if left equals 1, then just return the right. Otherwise, we can do the other stuff. Okay, so left equals same thing, 0, string low, false, false, 0, return right minus left. Actually, this should be low minus 1. Okay, probably about billionaires. Let's find out. Low. Oh, did we? There's no way. Holy shit, that's nuts. That's pretty shocking, honestly. Definitely thought I'd have an error somewhere. Because yeah, this thing it's pretty complicated. But yeah, that's kind of the idea for DigitDP, is essentially at every choice, you can either go 0 through 9, or you can only go 0 through your like upper bound. But you do want to make sure you don't include leading zeros, and so hopefully that makes sense, like why I have this, where essentially if we had leading zeros and we want to have another just leading 0, then it's just going to be like starting at the next number, right? So like if we're at 1 2 3 and our numbers so far this, and we want to just have another leading 0, that would just be starting here. We don't want to count anything here, like we don't want to count these zeros, we just want to start here, and we want to say the limit can be anything. And at the end, we can't have just like 0 0 0 0. So yeah, so this is, so we can just go through these. I mean, this is some 5. The important thing to recognize here is also like num will only be one of 2 numbers. So even though we're caching, it doesn't matter. Like this doesn't add much. This is also Boolean. This is also Boolean. So the only actual factors are I and digit count. So I is going to be log of, let's call it the high, and digit count. Yeah, the most it can ever appear. Actually, digit count is only like 10 at most, right? Like the biggest digit can be whatever, 2 to the 8th or 8. So this can only be 2, this can only be 2, this can only be 8, and this can only be one of 2 numbers. So it's basically just, this is like our thing. And then, so we do have to figure out like also how many times we're recursing here. So we're recursing 10 times. I mean, yeah, you can argue that's all constant. So this is like 10, 10, 2, 2. So you can argue it's just log high, I guess. And space, same log of the high. Yeah, honestly, pretty shocking that I didn't get any errors. But yeah, this is used for some problems, and basically the idea is like you have a decision to make digits something, and you can't just like manually go through all the numbers. So yeah, hopefully this is helpful. If it was, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.